last time we were dealing with the relationship between the kinetic energy and momentum. We were dealing with the relationship between kinetic energy and momentum. One case we have dealt was that kinetic energy when the lighter body, the momentum of the two bodies are same, then the kinetic energy of the lighter body will be more and that of your heavier body will be less. Okay, so similarly, that was one case, and I tried to explain you that case using an example also. Again, that is two bodies having different masses, and we were using it. Now today what we will do is we'll try to find out the relation between the two bodies if their kinetic energy remains same. Now, here what we are going to do is, this is your case 2. Where we are taking two bodies A and B such that the mass of A, B, M, small m, and mass of B is capital M, such that your small m is less than your capital M, which means that body A is going to be a lighter body, body B is going to be a heavier body. Okay. We will be taking the kinetic energy of both of them to be same. Earlier we were taking the momentum to be same. So let Ka be K and Kb equal to K. That means they both are having the same kinetic energy. So if we try to find out the momentum for A using the formula which we have derived, okay, we get it as for PA it will be under root 2MA KA, which means that this will be under root 2 small m into K. Similarly, if we try to find out the momentum for B, this will be under root 2 MB into AB, that is equivalent to under root 2 capital M into K. So if we find out the comparison, or if we find out the ratio between PA is to PB upon PB, we get it as under root 2 small mk upon under root 2 capital M into K. If you simplify it, you will get it as square root of small m upon capital M. Okay. So this is the relation which you will get. Now what does this relation indicates? Now we have already started, or we have already considered that small m is less than your capital. Okay. That is body A is lighter and body B is heavier. Therefore, if you try to find out from this expression, we find that momentum for A is going to be less than momentum for B, which means that a lighter body will be having a greater momentum and a heavier body will be having lesser momentum. All right. Now, what does that mean? So let us try to see this using an example. So up till here, I hope this is clear to all of you. Once again, I'll just quickly go through it. We are taking two bodies, A and B. A is lighter and B is heavier. So that the mass of A is a small m, mass of B is capital M. Kinetic energy of both the body is going to be same. So PA we get it as under root 2 mk, and PB we get it as under root 2 capital M into K. And finding out the ratio, we find it as square PA by PB, that is PA is to PB will be square root M upon M, capital M, which suggests that, or from this we can make out that a body with a lesser mass will have lesser momentum, a body with a greater mass will have greater momentum. Keeping the kinetic energy constant. Keep in mind, here we are keeping the kinetic energy constant. The kinetic energy is not constant, then the case may be different. Okay? Now let me explain you this using an example. So here again, we are going to take a body, two body A and B. Let MA be equal to 5 kg and MB is equal to 10 kg. Alright? So from here it becomes that A is a lighter body and B is your heavier body. Okay? Let the kinetic energy for both of them equal to 25 joules. So KA is equal to 25 joules and KB is also equal to 25 joules. Clear? Now, we try to find out the velocity over here because mass is already known, and to find out the momentum for A and B, we will have to find out the velocity of A and B. Now we all know that K is equal to half mv square, so V will be equal to under root and the value of under root 10 is approximately 3.16 meter per second. Similarly, VB, if we calculate, this will be equal to 2 into 25 upon 10. So this comes out to be under root 5. 5 ones are, 5 fives are, so square root 5, and the value of the square root 5 is 2.23 meter per second. Now if we try to find out the momentum, so momentum for A will be equal to mass of A upon the mass of A into the velocity of A. Mass of A we have taken it as 5. Velocity is taken as 3.16. It comes out to be your 15.80 kilogram meter per second. Similarly, PB, if we try to calculate, this will be 10 into 2.23. This will be equal to 22.3 kilogram per meter per second. Okay, so now if you try to find out the mass, lesser mass, lesser momentum, greater mass, greater momentum, keeping the kinetic energy same. So a lighter body will have a less momentum, whereas a heavier body will have more momentum if their mass is constant. So this gives you the relation between momentum and the mass if the kinetic energy is same. So I hope these two things are clear to all of you. If you have any problem, you can put your question in chat. Okay. So I hope this is clear to everyone. So this was the relationship between the mass and momentum, and in particular we were trying to find out the relationship between the kinetic energy and momentum, if the kinetic energy is constant or the momentum is constant. Now we move to the next portion, an important one, that is called as work energy theorem. So we move to the next one, that is called as your work energy theorem, and very important theorem. This basically gives us a relation between the work done and change in kinetic energy, generally increase or decrease in the kinetic energy. Now, according to the work energy theorem, it says that the work done by a force on a moving body in the same direction is equal to increase in its kinetic energy. It simply means that work done by a force on a moving body, okay, is equal to increase in kinetic energy. Okay, this is the work energy theorem. Okay, if you want to write down, I'll just repeat. According to the work energy theorem, the work done by a force on moving the body in the same direction is equal to increase in the kinetic energy. Simply means that, so for example, if I have a body and if I am applying a force and this force is causing the displacement in the direction of the force applied, so definitely he has to do some work from this point to this point. Okay, say if I mark it as A and this as B. So from A to B, the body has to do some work. And to do this work, it is using the kinetic energy, or rather the kinetic energy is going to increase. Suppose here if its velocity is u and it finally becomes v, then we find that here it will be having certain energy, kinetic energy. So here it will be having a kinetic energy K1, and here you will be having a kinetic energy K2. So because the force is being applied and the displacement is taking place in the direction of the force applied, therefore we can say that there is an increase in the kinetic energy, and since there is an increase in the kinetic energy, the increase in the kinetic energy is equivalent to the amount of work which is done on the body. Okay, and this relationship is called as your work energy theorem. Okay, if we want to write down mathematically, you can write down work done is increase in kinetic energy, that is W is equal to Kf minus Ki. This is the mathematical expression for work done, or you can also represent this as half m v square minus u square. Okay, these are the mathematical expression for the work energy theorem. Now, in this case, this is a case where we are applying the force in the direction of the displacement is taking place in the direction of the force applied. So here it will be increase. Maybe if you apply a force which is opposite to the displacement or which is against the motion, then in that case, the initial velocity will be more and final velocity will be less, which means that the body may be coming to stop or is decreasing its velocity. Okay, so we will deal with the derivation of the equation. So to derive this equation, what we are doing is we are going to consider a body of mass m. Let this be a body of mass m. Okay, and a constant force F is being applied and the force is being applied in the direction of the displacement. Okay, and this is going to produce an acceleration A. This produces an acceleration A and its velocity changes from u to v. The displacement taking place is s. So what we are considering is we are considering a body of mass m moving with an initial velocity u and a constant force F is being applied on the body in the direction of the motion. It produces, so when we are applying the force, it produces an acceleration A, and the velocity of the body, because it is producing an acceleration, is therefore the velocity is going to change, and hence we find that the new velocity will become v, or and it covers a distance s from initial position to final position. Now here the accelerating force which is being applied F, that is being given as m into a. That will be the first equation. Okay, and the work done over here, that is given as F into S. That will be equation 2. So force is m into a, the force which has been applied. Now we will try to calculate S, because we have to find out work done, so we should know force and displacement. So force, we are already knowing that this is equal to m into a, whereas displacement, if you see, so using the equation from third equation of motion, that is v square is equal to u square, and since it is acceleration, so plus 2as. So from here we get s is equal to v square minus u square upon 2a. So now what we have let it be third equation. So we have the value of force from the first equation, value of s from the third equation, and we put them in second equation. So from second equation we get W is equal to In place of F, we can write down M into A, whereas in place of S, we can write down V square minus U square upon 2A. If we cancel this, we can write it as 1 by 2M into V square minus U square. I'll rub the upper portion.
This magnet only strong. See
Or
just a minute. You can see this is lifting up.
W will be equal to
Just hold it like this.
half M
Just a minute. Just a minute.
V square
You can see it is lifting up. You see this?
minus
Very strong magnet.
half M V square. Now half M V square, this is nothing but your initial kinetic energy. We know initial kinetic energy can be written as half M
Sides and
U
picture
square.
compare.
And similarly, final kinetic energy can be written as half M V square. Therefore, W can be written as Kf minus Ki. And this is your work energy theorem. That means change in the kinetic energy is equal to the work done on the body. And this change in the kinetic energy will be in terms of the increase in the kinetic energy if the force is applied in the direction of the motion, and this will be equal to decrease in the kinetic energy if the force is applied in the direction opposite to the motion. So I hope up till here it is clear to all of you. All right. So I hope up till here it is clear to all of you. All right. So this was about your. Now, this finishes off with the kinetic and potential energy. Now we will be moving to the next portion, that is your conversion of potential energy into kinetic energy. Now before that, you will be noting down that I will be giving you the notes. I hope I have given already some of the notes. Whatever is not given, I will give you, try to send you. Okay. But for the conversion of potential energy, I'll give you the notes for different forms of energy and the conversion of one form to another form. This I would like that you should do it by yourself. Try to prepare a note by yourself. Let me see how you prepare it. Okay, these are the simple ones. So we start with the conversion of potential energy. Okay. Now, so conversion of potential energy into kinetic energy. Now we all know that the potential energy and kinetic energy is one of the very fundamental form of energy. So whenever we are taking any body, these two energies will be present. and they may be present as a potential energy, they may be present as kinetic energy, or sometimes they may be a combination of both of them. Now here we are going to take few examples and we will try to see how the potential energy is getting converted into your kinetic energy. Also, you should note down that whenever the energy transformation is taking place, which we will be studying in the next portion, okay, the last portion, that is, and if it is the potential energy, it is not directly being converted to some other form of energy, rather it will be converted to kinetic, and kinetic is then being converted into your other form of energy. So that part we will deal a little bit later. Now we start with the conversion of potential energy. Now few examples have been given, four examples have been given over here, and let me show you how this conversion is going to take place. So we will take the first example. The first example is if I take a stone at a certain height, okay, a stone at a height when made to fall, okay, we find that the potential energy gets converted into your kinetic energy. So how can we make out that it is having a potential energy and then it is getting converted into a kinetic energy? Very simple thing. You let that stone to fall on a piece of iron nail which is being placed over a wooden block. So we will find that this iron nail will try to get inside this block. Or if you don't want to stone, you can use a simple hammer. So when we are trying to nail a hammer, when we are trying to fix a nail in a block, we use the hammer. Okay. Now in this case, if you observe, if I take the stone at certain height, now at a certain height, the nature of energy which will be present, or the type of energy which will be present, that will be your potential energy. And most probably it is the gravitational potential energy, because when you are taking the stone from bottom to up at certain height edge, so it will be the gravitational potential energy which is present in the stone. Now what you do, you start allow the stone to fall. Okay. Now as the stone starts falling down, this potential energy gets converted into your kinetic energy, and it most probably be translational kinetic energy, really falling stone if we are taking in particular. Okay. Now what you have a nail at the bottom. So what happens? The stone has a potential energy stored in it. It gets converted into your kinetic energy, and this kinetic energy, that is the stone falls, or it will be falling on the iron nail. So now the kinetic energy of this falling stone will be taken up by the iron nail. Okay, this will be your kinetic energy of the stone being received by the kinetic energy of the nail. Okay, and as a result you will find that this nail will start moving inside the block. Okay, so that is how we find that the potential energy of the stone at a certain height gets converted into your kinetic energy of a stone, and this is imparted to the iron nail, and the iron nail also gains the kinetic energy. As a result, it is inside the block, or it goes inside the block. Okay, same thing happens if you replace the stone with a hammer. So the hammer is going to have the potential energy. When you bring it down, the potential energy gets converted into kinetic energy, and finally on striking the iron nail, the kinetic energy of the hammer will be transferred to the stone, to the iron nail, and iron nail in turn gives the kinetic energy and starts moving, and hence that is moving means it starts getting fixed into the block, and that is how we find that it is converting the potential energy to the kinetic energy. Then we have the second example. Second example is your wound up watch spring. Okay, wound up watch spring. This is, if you see, it's not only the watch spring, or you may have seen the key toys. Okay, you may have a car which can be wounded with a key, or you may have a helicopter which is going to be wounded, and then not the battery one, and then when you release it, the car will move forward, or the helicopter will start taking a rotation, or as it has been said. So here also, same case with the your nowadays we are having an automatic where the energy is being provided by the cell. Okay, but inside that also you will find there will be a spring inside of this chip. Okay, now this is basically being connected to the needles. Clear? So now when we are winding this spring, generally when we are keying in the watch, okay, earlier we used to have to wind it to let it work. Nowadays we are, the same thing has been done by the batteries or the cells which we are using in the. Now when we are winding it, what we are basically doing, we are making it very close by, and basically there is a change in the shape of the spring. As there is change in the shape of the spring, so what we will have, it will have potential energy, and in particular elastic potential energy. Now this elastic potential energy, when you release it, or rather when you leave it, you will find that this starts unwinding itself. Okay, it will start unwinding itself. As it starts unwinding, so what it is doing, it is basically getting converted into your kinetic energy, and in particular rotational kinetic energy. So your potential energy getting converted into your kinetic energy, and the needle which has been attached to this string, that will keep on moving. If it is your seconds needle, it will be moving continuously. If it is your minute, then after 60 minutes. If it is your hour, after 1 hour. Okay, so this is how the spring, here in case of spring of the watch, the potential energy is getting converted into your kinetic energy. Third example, when the string of a bow is pulled, that means in case of bow and arrow, bow and arrow. Now you might have observed nowadays a lot of serials have been coming. Okay, so you might have also been using bow and arrow. Now, if you see, this is a bow, this is the string part. Now, when you have to short the arrow, so this has to be pulled. So when you pull it, this becomes something like this with an arrow coming over here. Okay. Now, when you are pulling again, you are changing the shape. You observe this is a straight, this is a sort of bend. You are changing the shape, and as you change the shape, its potential energy, rather it stores a potential energy, and in particular elastic potential energy. Now you release it. So what will happen? This stored potential energy is converted into kinetic energy, has been imparted as a kinetic energy of the bow. And because of this kinetic energy, we find that it is going to make the arrow to move in. So this is how your potential energy gets converted into your kinetic energy. Similarly, In case of your compressed spring, fourth example is your compressed spring. Now, spring. Now, when you compress it, okay, so what you did, you apply a force and you make the spring to compress. So, what happened? The size of the spring has changed. That is, now this will be having potential energy, and in particular, your elastic potential energy. Okay, now what you do, you keep a ball over here, and then you remove this force which you are compressing, by which you are compressing. You will find that this spring again regains its own position and the ball is thrown up. Now what happens? Now when you are compressing the spring, it is having a, due to the change in the shape of the spring, it possesses the potential energy, and when you release it, this potential energy gets converted into the kinetic energy of the spring, and as it releases, this kinetic energy is being imparted to the ball also, and due to which the ball gains the kinetic energy and it flies off. Okay, so these are some of the examples where we find the kinetic energy, potential energy is getting converted into kinetic energy. Okay, so I hope these examples are clear to all of you. Second example, curve. Okay. Second example means wound up watch spring. Okay. Now, in case of wound up watch spring, basically it is a thin strip, circular strip which I had drawn. And once again, I'm trying to show you. Wound up watch spring, I'm again telling you, this spring is of this shape. It starts from one end and terminate. This is inside the watch. Okay, you will find this type of spring into different toys also. Now, basically, when we are winding it up, its shape changes. It becomes very closed by. Now, when its shape changes, it's basically the potential energy which it is storing in it now. Okay. Now, when it has been set to release, so what will happen? It will again start opening up. So as it starts opening up, so what happened here? It will be having an elastic potential energy, and here as it is opening up, so it will have a kinetic energy. So it is this potential energy which is getting converted into your kinetic energy, and that is how the needle which is attached to the spring will be moving, and the watch will be working. So this is basic concept regarding the wound up watch spring. So now we move to the next portion, that is different forms of energy. You all have studied about the different forms of energy. So I'll quickly go through. Now, when we are talking, see, energy basically is of some of these are your basic fundamental energies like your potential energy, kinetic energy, which together we call it as mechanical energy. Then some other important forms are your heat energy we have, We have electrical energy, we have nuclear energy, we have other. But in this case, if you try to observe some of the forms of energy, they will be of the same type form, but they will be named after the source from where we are receiving. So energy, wind energy, sound, magnetic, and mechanical energy. We begin with the solar energy. Now, solar energy, we all are aware, this is one of the prime sources of energy. This is basically the energy which we are receiving from sun. It's a form of heat and light energy. But because we are receiving it from the sun, so we call it as solar energy. Now, solar energy as such uh, is not very commonly been used, okay, or cannot be directly used to perform work. It has to be harnessed and then it has to be used. So one of the fact regarding the solar energy is that it cannot be directly used to perform work. Directly used to perform work. Okay. The other reason why it is not been directly used to, because it is diffused form, it is in the diffused form, is available in the diffused form, or it is not uniformly available. Uniformly. Okay. Yes, plants are using it directly, and there are various other. So I'm not saying that it cannot be used directly, but in most of the cases, it is not been used directly because it is either in the diffused form or it is not available uniformly. So the way in which we are using this solar energy is by using various solar gadgets. Okay, like we have solar panels we are using. Okay, we may be using solar furnace, furnace, solar cells. We have solar water heaters. We are using solar cookers. These you have already studied. Therefore, solar panels, solar furnace, solar cells. Solar cells you are already aware of. Okay, it's basically converting the electrical, the solar energy into your electrical energy. Solar panels are being used in the various ways. Either if you are using the solar cells, okay, then it is converting the solar energy into electrical energy. Sometimes solar panels are also being used along with your solar cooker. Okay, so that the heat can be trapped easily. Okay, and so say solar water heater and solar cookers, we can use these solar panels. And solar furnace is just like a furnace. Furnace means where the heat can be generated. Now here, furnace, in the normal furnace we are using the non-renewable sources of energy like wood, coal, petroleum products to have light and fire and heat. Here what it has been done, it is basically uh, a parabolic mirror has been used, or concave or convex mirror. Concave mirror is generally been used, okay, so that the heat is been trapped, because the heat of the sun is diffused form, so it doesn't reach to a very high temperature, but the same heat, if it is concentrated, to a small region, then it can increase the temperature of that region. So for that we use the concave or the parabolic mirror, where the heat has been reflected to a particular or is concentrated at a small point, and because it has been concentrated, it increases the temperature to a very high temperature, and therefore it can use to lit up fire, or it can use to lit up furnace, which can be used for the various purpose. So that is the purpose of solar furnace. Next is your heat energy. Heat energy you are already aware of. Okay, most commonly we are receiving the heat energy by burning of the non-renewable sources like wood, coal, gas, etc. Okay, and heat has got an ability to do the mechanical work in form of it converts the, say if you are heating water, it can convert water into steam, and that steam can be utilized to run an engine in the earlier periods. Okay, so that is how the heat energy gets converted to the mechanical energy. Then we have light energy. Light is a form of energy in the presence of which other objects are seen. Okay, we'll study light energy. Some as compared to heat energy, light is a weak energy, you can say, but at a places you will find that it is a strong also. So it is a form of energy in presence of which the other objects can be seen. That is one of the basic application of light. The natural source of light happens to be sun, and then we have the artificial sources where we are using the light energy. Even if you see, there are certain radiations, been colored radiations, which have been given out. Say for example, if you are heating an object, okay, you might have done flame test, okay, in class 9th. So there are different colors of the flame which has been given by a particular metal or metal salt. So that is again an example of the light energy. Okay. Then we have the chemical or fuel energy. Chemical energy possessed by the fossil fuels like coal, petroleum, they all are being present in the form of chemicals, and that is why the energy which has been released, that is called as your chemical energy. We are using these chemical energy or these fossil fuels in the form of fuel, and therefore we also call it as fuel energy. Then hydro energy, hydro means water. So energy possessed by the water, that is called as your hydro energy. Now hydro energy can be utilized in terms of your converting the now if you in particular if you see the what this hydro energy or water energy is basically the kinetic energy. Okay, but because we have kinetic energy we can receive from various sources. So to make it more clear, we put it as hydro energy so that the energy which we receive from water or which we are able to convert from water is called as your hydro energy, generally used to generate electricity in the dams and other places. Then electrical energy, one of the most common and very much required nowadays, okay, is your electrical energy. It's basically formed due to the movement of the charges. Okay, someone charges have to do some work. Okay, so generally in electric cells we are getting either we convert the chemical energy into electrical energy, or we convert the kinetic energy into electrical energy. Okay, so this is your electrical energy. Then we have nuclear energy. I'm just going through this because you have already studied all these things. So you also just go through it and just prepare a small notes on this. Okay. So nuclear energy, it is the energy which we receive due to the integration of the nucleus, disintegration of the nucleus, either through a nuclear fission or fusion reaction. Okay, integration or disintegration, you can say. And it has been said, Einstein's mass energy equivalence relation says that E is equal to mc square. So it means that if any mass which is moving with this velocity of light can be converted into energy. Okay, so constructive use is to convert this energy into a useful, that is electrical energy, and destructive use you all are aware in terms of the nuclear warheads. Then we have geothermal energy. Thermal already means heat. But geothermal means the heat which is present inside the earth. So we all know that inside the earth we have tremendous amount of heat energy present, and if we are able to use that energy, harness that energy, we call it as geothermal energy. So energy released in nuclear disintegration in the interior of earth gets stored deep inside the earth and is called as geothermal energy. This energy heats up the underground water to produce natural steam, and sometimes this natural steam may burst out of the from the surface of the earth as the hot spring. Electrical power companies may drill well into the earth to trap the natural steam, which may be used to run the turbine of the generators to produce electricity. This I have read out from your book itself. So this is the application of your geothermal energy, how we can use. Wind energy again is a type of kinetic energy, but sources, if we are considering it as wind, then this is considered to be as a wind energy. Then we have sound energy. So energy which you are receiving from me is the sound energy. Okay. So then magnetic energy, the energy possessed by the magnets, okay, due to the attraction of the iron fillings. So they also possess the energy. And then the mechanical energy. Mechanical energy we have already studied about them. So these are your some of the different forms of energy which you have to study. Okay. Now we move to the another major portion that is called as your conversion of one form of energy to the other form. Now, here I would like to tell you, whenever the conversion is taking place, it is taking place in accordance with the law of conservation of energy. That is, that is, energy can neither be created nor be destroyed, but it can be transformed from one form to the another. And the other fact says that the sum of the total energy in this universe is always constant. Now, whenever we are doing the conversion, it is there are two categories of energy which has been formed. So, energy conversion, if you see, it converts energy into two parts. One is your useful energy, and the other is non-useful energy. Now, what do we mean by this? In a simple term, say if I at present if you are requiring a fan to be working, now we require the fan for air, that means kinetic energy. So here electrical energy is getting converted into kinetic energy, but along with the kinetic energy it is also getting heated up due to the friction and due to the other factors, and therefore so your mechanical energy is getting electrical energy is getting converted into mechanical energy, it is getting converted into heat energy, it is getting converted into sound energy because you also hear some sound. Now, purpose of fan is to get the electrical energy, your kinetic energy. So kinetic energy happens to be the useful energy, whereas heat energy and your sound energy is your non-useful energy. So whenever this is taking place, whenever the conversion is taking place, we will always find that this gets converted into this. All right. So we'll deal with this in the next class because time is nearly going to be over. So we will be dealing with the conversion of energy, dissipation, that is your degraded energy, and then we'll deal with some of the numericals. So next class we will be doing this. So be present and yes. this heat and light energy are the part of solar energy, but together we say it as a solar energy when we are receiving it from the sun. Okay, is definitely calm. Okay, so this is uh, diffused form means it is spread. Okay, it is not very clearly been. Okay, so when you get the sunlight, it has been diffused and therefore it spreads out. So it is not concentrated at one part. Okay, Shlo, so I hope that is clear. Yes, light energy is also a part of solar energy, but sometimes we take, say for example, if we are using the torch, so we'll use it as a light energy. Sun also gives us light, so light energy. But if we are using the light energy and heat energy together, then we can call it as a solar energy. Okay, so bye for now. Please do your work. This portion you will prepare your own notes.